Hello, my name is EJ and this is Deep Learning Lab 4. Um, this lab focused on implementing deep learning uh, methods learned in class in some real life exercises. So the lab focused on text classification, that's using CNN and RNN and comparing the results of both models. And thirdly, the lab focused on image classification using convolutional neural network. Um, let's have a look at the first task. That was to use convolutional neural network for text classification. So here I do have my libraries. Basically the deep learning the neural network uses mainly the Keras library from a Python. Uh, so the first task was to read the data. So in my text classification part, I use the trace attributes data from UCI machine learning datasets, uh, and I focused mainly on two attributes of trace. That's the style attribute. That's what I use as my training set, and my target is recommendation given to the trace based on its style. That's my target. So I read the data and put it onto data frame, um, and the style data set is in form of text, so I had to encode using the pandas methods, that's get dummies, and then I put my data into the training and test set in the ratio of 20 to 80%, 20 for testing and 80% for training. And then I have my parameters for my model. I have embedding size, I have the kernel size, I have the number of filters, and the bool size. The bool is actually in form of matrix that will give me like a 4 by 4 or such matrix. Uh, and then here I created a instance of a sequential model. Created a drop out 25% of my data, and here I passed my I created a one-dimensional convolutional model. I use because it's the data type is in form of one dimension. If it was something like pictures, that could have been of that's multi-dimensional, like two-dimensional. So and then I created max pooling in form of a matrix. I picked like the highest value in a 4 by 4 matrix. I created a 4 by 4 matrix and pick each creator's value, the maximum value in the matrix. Um, and then I created LSTM model. Then the activations are used in all these models are the complex activation mode functions, like the sigmoids and the rectifier. And in this instance, I use the sigmoid activation function. Then I compile the data, and I'm interested in accuracy. and minimize loss. Then I feed the data on a training and on the training data, and then validate on test data, and then I printed out the accuracy versus the model score. So let's run these and see the results. So I can run the image classification in the meantime, since that one takes oh yeah, it is. So the CNN gave me a test score of 67% and accuracy score of 64%. So the second part was to implement image classification using the RNN. It's the same steps. The only difference is that the only difference here is that the model itself, instead of LSTM and the one-dimensional convolutional neural network model, I use a simple RNN model. I also used the sigmoid activation function and minimize the loss and measure the accuracy. Feed the data on a training set and validate on a test set, and then I printed out the model score and accuracy. So let's run this one and see what we have. I'm run this one too in the meantime, since it will take too much time. So this one actually have a less test score than the CNN model. The CNN model had 67% of test score, but this one has 65%, and this one has a far much better accuracy of 64.99, and the CNN had an accuracy of 64%. It's just a slight difference. And the fourth task was to do image classification. So here it's almost the same procedure, but I'll be using a two-dimensional convolutional neural network. So I have generate my training and test set using Keras image data generator, and then I transform my training and test data into a two-dimension of a 64 by 64, and then I have this. Since this is a predictive model, I put a picture overdock that I'll be using. That's a I'll be using my model to predict on whether this image is for the dog or for a cat. So I reshape my image to be of the same size as my training, of the same shape as my training and test set. And then let me see, I created a model, a sequential model, and here I'll be using a two-dimensional. Created a matrix, a 2 by 2 matrix, and pick the highest value in the 2 by 2 matrix. That's what the max pooling is. And then I also created another convolutional neural network that's of 2 dimension. Did a max pooling, and then I added a fully connected layer. So in image classification, I pass a rectifier activation function on the first layers, and then later on my last fully connected layer, I use a sigmoid activation function. And then I compile my model, that's to minimize loss and carry accuracy. I fitted the model on my training set and validate using a test set. So I have a lot of pictures. Yes, about 10,000. So for matter processing, I used 100 of them to make it faster for processing. So and then predict whether my image is for a dog or for a cat. So and then let's now run. I've run. So I have run my model, and here are the results. So it predicted accurately that my image is for the dog, and have 62% accuracy. So here was the image that I used just in case. And that's it.